point 1, point 4. First one, you just had to tell me each of the points. So point A was at, remember, it always goes X, then Y. So X, they label them here for you. So you go over 6, and then up 3. So the first one should have been 6, 3. B should have been 3, 12. Now the last two, you'll notice they are not on a line, they are kind of in the middle. So this next one here came over to about here, which I said was about 10, and then up to roughly 8. Okay, and then last one, D, is about 15, and then to me it looked like about 2. So 15, 2 for the last one. Next problem. You had a bake sale, and it said that you have, where was it here? You have 11 pies, and each one split into 6, and you're selling each piece for $1. So the first thing I found out was how many pieces I had. So I had 11 pies, each split into 6, and they said to solve it as a division problem. You could have also done, remember, 11 times 6, because both of them get you the same answer of 66. And then if each one's $1, obviously they would have made $66 for that bake sale. Next problem. Find the area in the perimeter of a rectangle that is 14.5 meters by 5.5 or 5.8 meters. So here's my rectangle. I should label it 14.5 and then 5.8. To find the perimeter, I add them all up. So I should have 14.5 and 14.5 because these two sides here, this side here, and this side here are the same length. And then two 5.8s because there are two sides that are that length. I add all those up. I should get 40.6 meters. Don't forget your units. The other part of that was finding the area. The area, I should have multiplied 14.5 times 5.8. When you multiply that, you should get 50.841. And remember, you have to look back into the original problem. 2 numbers after the decimal point, and your answer, 2 numbers after the decimal point. So the answer is 84.10 meters squared, because remember you're doing area, so it must be meters squared. Next problem. Good one. This is an old one. This is from probably one of the very first units of the year. Heading to find prime factorization. And remember, the easiest way to do these is with the factor tree. So here's my 30. And you keep breaking it up until you get all prime numbers. I know 3 times 10 is 30. 3 is a prime number. I'm going to circle that. 10 is not. 2 times 5 is 10. Both of those are prime. So my prime factorization is 2 times 3 times 5 for 30, that first one. I'll do 2 more, and then you'll have the last one on yourself to do. Next one, same exact thing pretty much, except it is 30. I can break that up into 30 and 10. And neither of those are prime yet, because 10 can be broken up into 2 times 5. And the 30 can be broken up into 10 times 3. And notice if I did multiply all these numbers right here, I still should get 300. So I'm just going to keep bringing these down because these are all prime. And this is 3, and then I break 10 up into 2 and 5 again. I multiply all those numbers together, I should get 300 still. So my prime factorization is 2 to the second power times 3 times 5 to the second power. Remember, this little exponent here tells me how many of that number we have. There are 2 5s, so that is why the exponent is 2. There are 2 2s. That's why the exponent is 2. The last one I want to go over is number 3, which is the number 17. 17, they're trying to trick you on this one, is prime. The only way to get 17 is 1 times 17. That's it. Okay, you can't break it up anymore. There's no way to make 17 with whole numbers. Next one. Copy the dot pattern below. You have to do the 5th and 6th figures. I'm just going to do the 5th one just to save a little bit of time. I think you can figure out how to do the 6th one. If you notice, the height is increasing by 1 every time. So if it's 4, I would have 5 dots. 2, 3, 4, 5. And then I believe I should have, We got 1, 2, 3, 4, 5, 6, 7 there. 1, 2, 3, 4, 5. Notice the bottom is increasing by 2, so I should have 9, 3, 4, 5, 6, 7, 8, 9. And again, you'd have the 6th one drawn as well. Describe figure 20. Well, I know figure 20 will be 20 high, because if you notice the height right here is whatever the figure number is, so it has to be 20 high. The other one I'd have to guess and check a little bit. It should be 39 for the bottom. Okay, so it'd be 39 this way, and then 20 high. And then it says how many dots are in that figure. Well, if it's 29 plus 30, we're looking at 59, except we can't count that corner dot twice. So I have to subtract 1 for that corner dot. So I get a total of 58 dots for that next problem. All right. Going on to one of my favorites, graphing. I love graphing. Problem 56. First thing you had to do is graph, and then find the shape, and then find the area and perimeter. It's in drawing. If you open it up, it opens it up for you. So we have plot the dots real quick. 1, 1. And then 1, 5. I have no idea what shape this is going to make yet. 5, 5. Okay. 5, 1. 3, 1. 3, 1. Right there. 3, 3. 3, 3. 2, 3. 2, 1. And then obviously 1, 1 again is back to the original. So here it looks like my shape. It said connect them in order. So you'll notice it almost looks like there's a doorway in this shape, right? That was one of the first problems. I think it then said to find the area and perimeter. Well, since it's on a grid, it makes it really nice. Perimeter, I can just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 for the perimeter. And then the area, I could have just counted the squares on the inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 for the area. Okay, and then you could just add units squared. Next problem. Ooh, pizza party one. I like this one. Okay, so it says one pizza equals 8 people. It can serve 8 people. And she has 28 people to serve. Okay, so again, I should be thinking, well, how many times this could be a division problem? 8 goes into 28. I know 3 times, and then there's a leftover, but we can't have people not getting pizza because we all love pizza. So that means I'm going to have to at least get 4 pizzas. Okay, because remember I knew it was like 3 and a partial. But you can't buy part of a pizza. So I know we have to get 4 pizzas. Each pizza costs $15. So if I get 4 of them, I have to figure out how much that's going to cost her. And we're not worrying about tax right now. So I know it'll cost her $60 for the 4 pizzas for this group. Next problem. Generic rectangles. All you have to do is fill in the missing sides and find the areas. I'll do the first one for you and maybe start the second one, but then you're going to have to be on your own to solve that one. So I think this one here is probably the easiest one to figure out. 20 groups of 6 is 120. Now I have to do some solving. 20 times something will get me 1,600. I know 2 times 8 is the 16. And then since it's in the tens place, I know it has to be 80. Now that I have that one, I can figure out what this left side is here. 8 times 7 I know is 56. So it's 7. And then 7 times 6 is 42. Last part, the thing I had to do is add them all together. So when I add these all together, I'm going to combine the 200, so I get 680. And then another 42. When you add those all together, you should get a grand total of 2,322 for that problem. Second problem, done the same exact way again. We've done generic rectangles a lot. So this one, I'll help you find the outside, but you're going to be left for the inside. So outside here we can figure out by using this number here. 5 times something is 45. That something is 9. Has to be 9. All right. Next one. 30 times something is 2,700. And I know 3 times 9 is the 27, but it has to be 90. All right. And then I'm left with one more to figure out on the outside, which is something times 9 is 36. I know 9 times 4 is 36, so it has to be 400. And then you have to figure out the inside and actually find out what the answer actually is going to be. Right? Next problem. This one, all you had to do, there's nothing to solve. All you have to do is write that problem as a division problem. Or if you want, you can tell me the answer for each, and I'll tell you both. I'll tell you the division problem and the answer for each. The first one, okay, you have 1 soda. You're going to divide it with 2 people. There's your division problem, and that's actually your answer. Each person gets half a soda. Number 2, it says 2 people share 3 hamburgers each. So again, the top number, that tells you how much of something you have. So this is how much. Okay? And the bottom number here tells me how many times I'm sharing it. So I'll just put how many times I'm sharing it. Okay? So if I use that same thinking here, the second one, well, I have 3 sandwiches, or 3 hamburgers, with 2 people. There's my division problem, and that is the same as 1 1/2. Number 3, I have 1 large box of fries sharing with 3 people. 1 large box of fries, 3 people should be 1/3. Number 4, 3 people share 7 brownies. So number 4, there are 7 brownies and 3 people, which is the same as 2 1/3. Next one, I'm going to have to scroll down for number 5. Can't quite see it. So I'll leave that up there as an example. Number 5 says 2 people share 5 apple turnovers. So you have 5 apple turnovers shared with 2 people. There's your fraction and answer and division problem. And your answer is 2 1/2. Number 6, 5 people share 3 cartons of chow mein. You have 3 cartons, share with 5 people. There's your fraction, your answer, and division problem. Last one is a good review problem dealing with fractions, decimals, and percents. They give you the percent. All you really have to do is tell me what the fraction would be and what the decimal would be, and it wouldn't hurt to draw a picture. So I know 145% is 1 whole and 45 more out of another one. So I got the fraction 1 and 45 out of 100. The decimal, I know I have 1 whole, so I should have the decimal 0.1 or 1 point. And then the decimal should just be 0.45 because I have 45 hundredths of another one. That's what my fraction tells me, 45 out of 100, 45 hundredths. Then obviously if you had a picture, you would have 1 whole hundredths chart filled in, so this is a 100 chart. And then another 100 chart with maybe 45 shared in, 45 shaded in the second hundredths chart. These are the answers to 6.1.4. Good luck.